Hello everyone, thanks for joining my YouTube channel. We're going to start our second part of the Cisco SD-WAN technology, and this session is basically going to be a quick review of the SD-WAN architecture and the functions of the equipment in the SD-WAN fabric. We're going to see how you can set up the lab in JNS3. There is a playlist about that, but I'm going to review the steps, and we're also going to see the lab setup that we have. We're going to the lab that we're going to use through this series of videos. I'm going to show my topology, the first thing that I need to do. So in this lab, we're going to use this topology. We're going to have 4 sites: site 11, site 22, site 33, site 44, and these sites are connected through 2 transports via the internet and the MPLS. And the 4 sites are going to connect with the data center, which hosts our syslog server, the web server, the SNMP server, the TACAC server, and also the DNS, NTP, and DHCP router. We also have the HQ, the headquarters, which is in Los Angeles, and we going to add a couple of servers and other stuff as we move along. As we know, in a SD-WAN setup, the devices at the sites, at the remote sites, are managed by controllers. So in this lab, we have 2 sites which will host the controllers. This is for the sake of redundancy. We have site 1 and site 2. So I'm going to update this. We have site 1 and site 2. So we have one vManage at both sites, and one vSmart at both sites, and also one vBond at both sites. And just to recap, so the lab setup, we have 2 vManage controllers, we have 2 vBond controllers, we have 2 vSmart controllers, we have 8 vEdges, we have 8 Ubuntu servers running on 18.04. We have 2 FortiGate firewalls. We're going to use these firewalls kind of to show at the data center. We're going to see how to connect to the internet via the data center. But at one of the sites, I think it's site 11, we're going to use it basically to do some packet captures. We have the TACAC server. We have one Windows PC which is going to run the SNMP server. We have 8 Cisco switches and 4 Cisco routers. The first thing, quick review of the SD-WAN architecture and functions. The main planes and functions in a network. So basically, in order to understand the SD-WAN technology, it's kind of important to understand the main planes in a traditional network. In a traditional network, we have the management plane, the control plane, and the data plane. All these planes will be in one piece of hardware, like a router or a switch. We're going to have the 3 planes in the same equipment. We're going to have the management plane, we're going to have the control plane, we're going to have the data plane. All these planes in a traditional network are going to be on the same routers, on the same router or switch. The management plane is basically where we use protocols that are going to help us manage the equipment, monitor and access the equipment. So basically, when we talk about SSH and all those stuff, we are at the management plane. Okay, so let me give some details about how the control plane interact with the data plane. The control plane is where protocols such as OSPF, EIGRP, and ARP do the work to populate the tables. When I'm talking about the tables, it's basically the ARP table, the routing table, and the safe table, and any other tables that are at the control plane level. And those tables basically will instruct the equipment, the router or the switch, on how or where to send traffic. So let's say this is a router. OSPF has all the process, the messages like the LSA, link state advertisement, and other types of messages, okay, that OSPF use to receive information about the network from neighbor routers, okay. And once this router receive all those info, it's going to know where to send packets. Okay, it's going to say, okay, if I receive a packet going to 10.10.10.10, I'm gonna need to send it to GE01. Okay, so OSPF is at the control plane, and the interface that's going to send that traffic is at the data plane. So basically that's how you can summarize both planes, the control plane and the data plane. In a traditional network, all these functions are on the same piece of hardware, on the same switch, on the same router. In a SD-WAN implementation, basically SD-WAN is a SDN implementation. SD-WAN, software defined wide area network, is a software defined network implementation. So basically what it means is that the data plane is decoupled, is separated from the control plane and the management plane, and this is called a distributed architecture, because those planes are kind of separated. They are not on the same piece of equipment, they are in separate equipment, in different equipment. So we're going to see this in more details. Okay, in a SD-WAN network, we have two types of devices. We have the controllers, the vManage, the vBond, and the vSmart, and we have the WAN-edge devices. And these WAN-edge devices, we have two types of WAN-edge devices. We have the V-edges and the C-edges. The C-edges were created by Cisco, and the V-edges by Viptela. And just to give a short history, the Cisco SD-WAN technology has been invented by Viptela, and Cisco bought Viptela. So that's about the planes. Let's go to the next slide to review the equipments and what they do actually. So the first equipment that we're going to review really quickly is the vManage, which is the management plane of the Cisco SD-WAN technology. Basically, the vManage, the work that vManage does is the onboarding, is to onboard devices. It's going to onboard the controllers and the V-edges. To give an idea of what this means, if I go to this vManage, I'm gonna make it a little big. Looks like it's okay. I need to authenticate again. Okay, so it's too big. Okay, so onboarding just means if you would like to add a device to your Cisco SD-WAN network, you need to go to device, and if you would like to add a controller, you come to controllers, add a controller. You can add a vBond or a vSmart. Regarding vEdges, you need to upload the vEdge list. That's how you add a vEdge in the vManage. And there are other stuff that are related to onboarding. Basically, the certificates. This is a long process that we covered when we went through the first steps, and I'm going to summarize this step. Basically, each equipment in the SD-WAN network need to be authenticated. And what that means is that I'm going to give an overview of that. Okay, let's reserve that for the section where we're going to summarize the steps. Okay, let's go back. So onboarding, you add the devices to vManage and you integrate them to the SD-WAN fabric. Provisioning is basically the configuration part of the technology. How you can configure your devices. In a traditional network, we have to go in each, like if you have 50 routers, you need to go to router 1, you type the comments. You need to go to router 2, you type the comments. There is a big change with Cisco SD-WAN. With Cisco SD-WAN, you can go to your vManage, you go to devices, you go to configuration, and you go to templates. What vManage does is that you have two types of templates. You have the feature templates, which allow you configure technologies, specific protocols or technologies, and based on the equipment model. Okay, so let's say I'm using the vEdge Cloud, so I can configure a template for AAA, for archive, banner, BFD, BGP, bridge, DHCP server, IGMP. So these templates, when you let me go back, I have a couple of templates, like a template for NTP, Network Time Protocol. They basically look like this. So this is a template. It does not look like a configuration. That's a big it's an easy way to deploy your devices. So basically, if I would like to configure NTP, we will go in the details, but I'm just showing the basic stuff. So I can come here at the IP address of the NTP server. If there is any authentication key, I will add the authentication number. And the VPN is kind of like a verb. I will add the version, the source interface, and if I want it to be NTP prefer, I can also select on or off. Authentication is basically where I can add like a key to authenticate the devices that will communicate with the NTP server. So this is how it looks. But when you go to device templates, let's say let's select one of the devices. No, that's not what I want to do. I will go back here. I will go back to devices, show attached devices. That's not what I want to do. Okay, I need to go back to devices and check the running config. Yeah, running config. You see, this is how the config we just went through NCP. It's kind of like a GUI based in vManage, but the config on the device itself will look like this. Okay, so we went through the key. Sorry, let me close this. The key, the IP address of the server, the key number, the source interface, the VPN, and the version. So you can see how it looks on the device. So one of the good thing with SD-WAN is that deployment of your configurations is really made easy. Let me give an example. Let me go to templates. I'm gonna use the device template. The device template is composed of several feature templates. Let me show that. If I go to edit, you see this device template will take a lot of feature template, like the system edge, the archive template, the logging template. All these are feature templates. So the device template will put them together, and this will allow you to deploy the config. Let me give an example how you can how easy it is to deploy a config. I'm just going to change a value on one of the devices. It's not I'm going to change something that's not going to be service affecting, I mean based on my network. So this is just and I'm not using this interface, so I'm gonna change this IP address to 35. Okay, so I'm going to update, and this is the VHS33. I'm going to update. Next, the VHS33 is the last one. You can see this is the current config on that device. If I go to config diff, I can see the line that's going to be changed. I'm changing this IP address from 33, the line that's going to be deleted, to 35. You can also set the rollback. Basically, what this allows is is just if you lose connectivity, if you deploy a config on a device and that device lose connectivity to the vManage, you can the config is going to be rolled back. You can also add exceptions, like if you don't want the config to be rolled back, you can add some exceptions. I'm not going to do any of this, that just to give an idea. And let's go and deploy the config. So before doing that, we see this is on 33. I'm going to bring that device and we're going to see. So we're going to log into that device and see the IP address. That's going to be changed before making the change. And you see this, you're going to access to your vManage to make the changes. Show interface description. We can see this is the IP address I would like to change. So I will go back to vManage and configure the devices. This is a good thing. You can deploy a config on several devices in one click. Okay, you adjust your device values, and then you can apply the change in one click on all devices. I will say yes, and I can say okay, and vManage is going to schedule the config deployment on all the devices. You can notice that I did not change on any other device, so all the other devices are going to keep their config in the same state, but the one that on which I made the change is going to be affected by the change. So let me go back here and see. Let me go to the dashboard. Okay, so successful on the two first devices. And this is also good. You can monitor how the configuration is being applied on your devices, and you're going to receive also, I think, some alerts on some changes. So that's Let's go down. I think it's done. Yeah, it's done on that device. If we go back here, we check again. You see, we just changed this IP from 33 to 35. So that's another advantage of using Cisco SD-WAN. vManage is going to be the place where you're going to create your policies. It's also going to be the place where you're going to do the software management. We know it's not easy to manage software on a traditional router. You need to transfer the files and also go through some long steps. But with vManage, it's really easy. You can come to the maintenance, software upgrade. You can, what you're going to need is to have a repo. So you're going to kind of have, you can add a software in vManage. Okay, the software is going to be in vManage, and then you can deploy it on other devices like the other controllers, vBond, vSmart, or the vEdges. You can also deploy a config which is in the a software which is in the vManage repo in the vManage itself. So let's go back here. I can add a software if I want. I can add a software on vManage. I can add it on a remote server or a remote server vManage. So you have all these options. So if I want to upgrade for like the controllers, the good example is my vSmart. My vSmart are running actually 16.3.2, but there is a version available. So I can upgrade this vSmart to 17.2.0. So if I would like to do that, I can go to upgrade and I can choose and I can activate and reboot. So that's how easy it is. This is really fantastic. And if we go back here, vManage is also where you can troubleshoot and do your monitoring. The dashboard itself, the main dashboard, is kind of gives you a lot of stuff that allow you to monitor the network. Let's say this. Let me cut down a cable on the topology. If I go and disconnect one of the devices like HQ2, so let's say that's a fiber cut. Let's give an example. That's it's a fiber cut. Okay, I just disconnected one of the cable on the GNS3. We're going to lose connectivity to one of the devices, and that's also a way to, when you're monitoring the network, you're going to know, oh, that device is not reachable anymore. You're going to see, yeah, it's down. Okay, and it's going to tell you the device that is down, the HQ2, and you can, I'm gonna put that cable back. Okay, you can also monitor the reboot. Okay, and you can see sites that are full connectivity, and if there's any site that has partial connectivity, you're going to monitor the bandwidth utilization. It's going to show you the health, warning errors. You're going to see transport health if there is any latency. Okay, packet loss. If we come here, packet loss, latency. Okay, it's showing these graphs, and also the jitter. You can see that's basically. But if you go to network, okay, we can also see alarms. You can see the alarms that you have in your network. Okay, for this we have this alarm. I think that's the link that was just down. Okay, the link that I just disconnected, yeah, the link going to HQ2, it's showing that's critical because vManage could not connect to that device. And alarms are classified in several categories. We have the critical, the major, the medium, and the minor. So that's about the alarms. You have the events, everything that's happening in your network. Okay, everything is recorded here, and it's going to classify those events based on either they are major, minor, or critical. We have also the audit logs. Okay, and let's go back to network and go, let's say we're going to choose this device at DC1. This is the dashboard of a specific VH. Okay, this is the dashboard that's allow you to check how healthy a device is. If that device is rebooted, it will show here the module. We basically, this is a this is a virtual equipment on GNS3, so there are some stuff that we can't see, but it will show you if the device has several modules. It will show you the temperature sensors. These are critical, these are really important stuff. We know that can allow you say, okay, something is wrong with this equipment. Crash, if there are some any sort of issues. You have the power supply, the fans. So it's going to give you an overview of the hardware, CPU utilization, and memory utilization. We know if your memory is running high, it's going or even the memory and the CPU, if both are running high, that's going to cause issues. So this is really good stuff to keep an eye on. And you can watch this stuff in real time. You can go by hour, 3 hours, 6 hours, 12, 24, 7 days, or you can customize your filters. So that's the dashboard. And we have a couple of other stuff. We're not going to cover all of them today. We have the flows, we have the WAN, the T-log, the tunnel. Most of this stuff are going to be covered when we move along. You have the control connections. So basically, this device is maintaining a control connection with 2 vSmart, and 1 vManage. We have the system status. This is what we saw. You have the events. You have the ACL logs. You have the troubleshooting. So this is going to give you an idea of some stuff like the device bring up, the ping. You can ping from here. You don't have to go to the CLI to do your ping test. You can do a trace route. You can check the tunnel health. Okay, uproot virtualization. You can simulate a flow. So let's go just with a trace route for now. We're going to ping an IP address which is at the site 11. So basically, just to give an idea, we're going to ping from this to this switch. Okay, and it's going via the internet. Just to give, the MPLS side is not set up yet, so we only routing via the internet. I will go back here. So we're going to use VPN 10 because this is the service side. We're going through the details. You can go with the additional the advanced options, like the size of your packet. Okay, it's going to be like 56. Okay, let me just say, okay, I want to ping 1000, the size of my packet, or the trace route, sorry. The size of the packet on the trace route. So you can see it's gonna give you like the path, okay, and it's gonna give you the latency, which is really good. You can really monitor your network via the vManage dashboard. So let's go back to the next controller, which is the vBond. vBond is actually the device that the controller that authenticates all the devices that would like to participate in the SD-WAN fabric. So any device that will that is being integrated in the SD-WAN fabric will need to talk with the vBond, and vBond will authenticate that device, and then that device is going to be part of the SD-WAN fabric. If we go to this device, if we do show control connections history, we can see the history of the control connections between this device and the controllers. I will add the tab, that's where you can get the same stuff here. So you can see this device, the VH at site 33, went through some authentication steps with the vBond. Okay, what we need to know is that once the device is authenticated, the control connections with the vBond will be terminated. So I think here we have the control connections with vSmart, and then here with vManage, this one with vBond, and then these two with vManage, and then these two with vBond. Okay, we have two vBonds, so two control connections, and tear down. So that's basically about the bring up, the authentication that vBond perform. vBond is also responsible of NAT, network address translation. If any device is beyond a NAT device, the IP address of the VH, let's say the IP address of the VH is being translated, vBond is the one who is going to do the NAT on the SD-WAN side. vSmart is a control plane. Basically, it's the brain of the SD-WAN fabric, implementation of control policies. Centralized data policies, localized data policies, service chaining, VPN topology, security, and encryption. So vSmart is really a critical piece of controller in the SD-WAN fabric. Just to give an idea about topologies, by default the topology that is established on a SD-WAN network is a full mesh. So that simply means when you bring up your SD-WAN for the first time, when you implement it for the first time, all devices will talk with, all sites will communicate with every other site. Each site will communicate with each other, with all other sites. Like this site will communicate with the DC, with the HQ, with site 22, with site 33, with site 44. Okay, there is going to be a full mesh, and you might not need that. You might not want like branches to have communication, direct communication between them. You might need them to go via the data center before heading down. So you can go with like a hub and spoke, okay, hub and spoke topology, or any other setup you'd like to do. So all the policies are going to be implemented at the vSmart. Just to give an idea, if I go to the vManage configuration policies, we have the centralized policy and the localized policy. The localized policies are going to be implemented at the device level. The centralized policy is going to be implemented at the vSmart level. So if I go, you can there are these steps. You need to create groups of interest. The application, you can create you can deploy your policies based on application, based on the color. The color is related to the transports. Let me go. I'm gonna give an idea. VPN 0, interface G00, tunnel interface, color. If I do color, we have all these colors. We have 3 gig, Biz Internet, blue, bronze, custom 1, custom 2, gold, gray. So these are the colors. The colors is just like an identifier of the transport. Most of the time we're going to use maybe the internet and MPLS, and you can specify that this interface is internet or this interface is MPLS. And this is going to be really important in terms of the tunnels that are going to be created in your SD-WAN fabric, because when you say, okay, this interface has okay, let me give an idea. So let me say show running config VPN 0. For this interface facing the public internet, the color is Biz Internet. So the tunnels are going to be created. If you don't, I'm not going to the details, but you can create tunnels between interfaces that are using the same color, or you can create tunnels with interfaces that are running different colors. So that's how you some basics on how you deploy your topologies, because tunnels are where your traffic, your data plane traffic is going to run through. So the service traffic, traffic that will be coming from one site going to the other site. And let me go back. You can also create your policies based on data prefix, policer. This is basically QoS prefix. You can create your policies based on site if you'd like a site to talk with another site, or if you would like to create some topologies. SLA class, you can use the TLOG, the VPN. So there are all these stuff that you can use. And that's basically for the smart vSmart. vEdges are where the SD-WAN overlay traffic flow through, the user traffic. So basically that simply mean, if you go back here, traffic coming from site 11 will be coming, let's say, from this PC, will go through the switch. This is the service interface. The interface facing the site is the service interface. The interface facing the transport side is the transport interface. Let me say, this is the transport interface and this is the service interface. So traffic that will be coming from the site will enter the tunnel, okay? And then that traffic, let's say it is being sent to the data center. That traffic will flow directly to this interface. And that traffic is not going to be visible on the transport side, because in SD-WAN, in Cisco SD-WAN, all those tunnels are IPsec. And you see, the good thing is that you don't have to configure those IPsec tunnels. They are automatically built by the controllers. So that's about the user traffic. It's is the traffic that's going from one site to the other site. Let's go to the next slide. Okay. If you'd like to set up a lab on DNS3, you have two options with a Cisco Smart account. In this case, you need a viptela file. So you need to download the WAN edge list from the Cisco Smart account. And if you use this process, you don't need to authenticate your devices manually. But if you don't have access to a smart account, just like me, I don't have access to a smart account, so I had to set up my lab manually. So I will give you a summary of what you need to do in order to set up your lab on GNS3 without a smart account. If you'd like to set up a lab without a smart account, you will need to sign certificates manually and onboard OneEdges using an Excel sheet file. All these steps are in a previous playlist that I'm going to show. So you need to go to the main page of my channel and you go to playlist. Okay, if you go to playlist, there are two playlists that you need to check. Sorry, there are two playlists. Oh, let me just, looks like, oh, it's not showing me the playlist. Okay, so there are two playlists. You can search for this playlist. This playlist contains the steps that you need to follow in order to install your certificates, onboard your devices, do all those steps. Let me tell you, all those steps have nothing to do with networking. That's just like steps that you kind of need to go through in order to build your SD-WAN lab. I'm gonna give some info about the versions that you need to use. On the vManage, you going to have to start with version 16.3.2. Why? Because this is the version that allow you to upload an Excel sheet file manually. Okay, if you use any other version like 17, it's not gonna work. So you need to start with this version. On the vBond controllers, vSmart, vBond controller anyway is used just the same image as the vEdges. So just to summarize, for vSmart, vBond, vEdges, you can go with version 17. The reason why you need to start with version 16 on the vManage is because that's the only version, as far as I know, that's going to allow you to use an Excel sheet to upload